Hey everyone, today we're going to go over this question, merge two binary trees. The question states, given two binary trees, and imagine that when you put one of them to cover the other, some nodes of the two trees are overlapped, while the others are not. You need to merge them into a new binary tree. The merge rule is that if two nodes overlap, then some node values up as the new value of the merged node. Otherwise, the not null node will be used as the node of the new tree. And they give an example here. So basically what this question is asking here is, given these two trees, T1 and T2 here, they're asking if you were to take them and overlap them like this, for the nodes that overlap, then they want you to add those nodes together. And then for the nodes that don't, they want you to place them in the new tree. And as you see in the answer here, these two added make 3, 3 and 1 make 4, 3 and 2 or 2 and 3 make 5. And then since 5 is not in this tree, it's put here. And since 4 and 7 are in tree number 2, then they're there as well. All right, now we're going to go through the algorithm step by step and use the example here that they gave us. So first off, in order to get this answer, we're just going to be making changes to T1 and then returning T1 and the end. So the first step of the algorithm is, first we got the function name here, so merge trees, and then they give us T1 and T2. So I'm going to be making the function recursive, so we only need to deal with each node one by one and not really think about what's going to happen later in the tree. We just deal with the current node and its left and right children. So I've got these stars here to help make it a little bit clearer where we are in the tree. So let's start. Step 1 is to check if there is a node that exists. So because if one of them don't exist, then we just want to return the tree that exists. So in the first step, imagine if there was no tree 2 at all, we would just return T1 and that would be the answer. But since that's not the case, we want to add the current nodes together. So 1 plus 2 is 3. Cool. Now, since this is going to be recursive, we want to repeat that same process for the subtree on the left and the subtree on the right for both cases. So I'll write that out. So here we check if both exist. If not, return existing tree. And if both exist, add T2 to T1. And then we want to repeat this. We want to set left subtree to the merge tree of T1.left and T2.left. And we want to repeat this for right side. Do the same. Cool. And then in the very end, we're gonna return the tree because then it'll have merged both trees together. So return T1. All right. So going off of this, let's see. Just move this to the left here. Okay. So now we go to the left. So now we're in the left merge, and this 2 is on the left. Since they both exist, we add them together, and so now this is a 4. And then we are in the left tree again. So now go here, and we go here again. So since 5 exists and there's nothing here, we just we return this 5 here back to the left subtree of 4, so that stays the same. And then now the left side is done, so we're back to the 1. And then since we completed the left side, we got to do the same for the right side. So now here, there's nothing on this right side, but oops, this will be a little hard. There we go. Now on the right side, there's nothing here, but there is a 4 here, so we want to return this 4 back up here. So I'm going to take this and just make a little duplicate show and return that here. Actually, first. Cool. So now 4 is done, so we return T1 back to 3 here. So now the whole left side is done, and then we repeat on the right side. So now we're on the right. Since they both have nodes, we add them together. 3 plus 2 is 5. Cool. And then we repeat for the left. There's something on the left here. And then we also do it for the right side here. So there's just a 7. And so we repeat that same process back there. 7, and then duplicate here. Now we're back at the top since we've done both the left side and the right side, and we return T1, and that should give us the answer. Okay, now we're writing the code. So I took the algorithm that we came up with here in the whiteboard and then put them into comments. And so let's get started. All right, so first we check if both exist, and if not, then we return the existing tree. So essentially that means if one of them doesn't exist, then we should return the other one. All right, so if not T1, then return T2, and if not T2, then we return T1. There is also a case where they both don't exist and they're none, so the end result will be none, and none would be returned. All right, next step is, so if they both exist, add to T1. So in the case that they both exist, we add the value of T1, or we add the value of T2 into T1. So T1.val plus equals T2.value. Now we set T1.left to merge trees on the left subtree of T1 and the left subtree of T2. So here's the recursive part. We take T1 left, and then we call this function merge trees on T1.left and T2.left. And then it'll repeat this whole process. So if one of them doesn't exist, it'll just end up returning the subtree. So yeah, here imagine that T2 goes to the left, and then we go to left here. There's a 5 here, but there isn't a 5 there, or there's nothing there. Then we just return the 5. And lastly here, we return merge trees for the right side as well. Let's take that and merge trees T1.right, T2.right. Lastly, returning T1, because by this point we will have merged all the left side of T1 and all the right side of T1 with T2. So we return T1. And just like that, I believe if we submit, then we finished, and with a acceptable runtime and memory usage. Thanks for watching, and I'll catch you in the next one.